At the end of this experiment, we are able to, firstly, to determine the relationship between force and the extension of spring. Secondly, to resolve the effect of stretch of spring when the masses added. Lastly, to find the value of spring constant.
We can use Hooke's law to find the spring constant.
Now, let's talk about the introduction of this project. Hooke's law teaches us how springs can store and use potential energy. It is expressed as a ratio of the force needed to stretch spring and the distance is stretched as K equal to F over X, where K is equal to the spring constant, while F is equal to the force used to displace the string, and X is the extension of spring. After this, we will show you a simulation lab on how to find the spring constant by using F is equal to the m times g, where m the mass of objects, while g is the acceleration of gravity, which is 9.81 meter per seconds power of.
Hello everyone. This is simulation we are going to use the one called lab. So we click lab here. Okay, now you can see there is a spring strength, mass, ruler, and timer. But we are not going to use the timer. Okay, what we are going to do is we are going to change the mass that we add to the spring, and we are going to measure the stretch of the spring. So to do that, we need to click on stretch length. That will give you the starting position of the spring here. And then click resting position so that it will give you a mark again when we put a mass on to stretch. So I will go through how to do with 50 gram. Before that, we must fix the spring strength because we want to find the constant spring. So I will choose here. Okay, this one. We must fix the spring strength first. And then we reset the mass. We want to use 50 gram. Okay, now I already add 50 gram to my spring. And there is the blue line and the green line. So the length of the stretch of the spring. Now we take the ruler to measure the elongation of spring. Okay, we stop here. So the measurement is 7 centimeter. Okay, repeat the previous procedure followed by the mass of 100 gram, 150 gram, 200 gram, and 250 gram. Okay, now we use 100 gram. Oops. Okay. And the measurement of elongation of spring is 14 centimeter. Okay, next we use 150 gram. Okay, click the red button. Now we see that 21 centimeter. Okay, next 200 gram of mass. Okay, click the red button. And now we can see that the measurement of elongation of spring is 28 centimeter. And the last one we use 250 gram here. Okay, the measurement of elongation of spring is 35 centimeter. Okay, so that's what I will record in my result table. Thank you.
So, this is our data and observation.
We are going to talk about the discussion of this project. Based on the data, we found that the spring constant is actually the slope of the graph force versus extensions because of the mass or the force that we applied to the spring. Since the force is directly proportional to the extension, when the force increases, the extension of spring also increases and vice versa. When the slope of the graph is determined, we also can find the spring's constant by using equations k equal to f over x, where f is equal to mg, then k is equal to mg over x. This project is related to Newton's law of universal gravitation. According to this law, gravitation is the force that attracts objects toward each other.
After this experiment has been conducted, both the Hooke's law and the graph give similar result, thus proving the hypothesis. We can determine the stiffness of the spring is the spring constant, which is 8.21 Newton per meter. The bigger the spring constant, the shorter the extension of the spring. The experiment is related to the theories. We also can determine the relationship between force and the extension of spring. The higher the force, the longer the extension of spring.
Thank you for watching.